Hello students, let's continue with exercise 1.3 of number systems. So we are on question 7. Write down 3 decimal expansions whose decimal expansions are non-terminating and non-recurring. So according to this, let's read. Decimal expansions are non-terminating or non-recurring. These type of decimal expansions are true only for irrational numbers. That means we have to mention any 3 irrational numbers. So remember, we learnt in one of our previous classes, that decimal expansions of numbers that are positive integers but are not perfect squares are irrational, right? Similarly, the decimal expansions of integers, positive integers that are not perfect cubes, are the cube root of those numbers are going to be irrational. So let's list down these numbers. I'll write answer. We have root 2, root 3, root 5, root 7, root 10. Okay, see 2, 3, 5, they are prime numbers. So the prime numbers, the decimal expansions are going to be non-recurring and non-terminating. Now look at this, 7 is neither a perfect square nor a perfect cube, right? So the square root of this is going to be non-recurring and non-terminating. 10 is, even if I write cube root of 10, now 10 is not a perfect cube, so the cube root of 10 is going to be non-terminating and non-recurring. So all these are irrational numbers. In short, for this, the answer for this question is, we had to list any 3 irrational numbers. So let us read the second question, the 8th one, find 3 irrational numbers between 5 upon 7 and 9 upon 11. So let us first find the values of 5 upon 7 and 9 upon 11. So 8th sum, 5 upon 7 and 9 upon 11. We need to find irrational numbers between these two numbers. So let's find the value of 5 upon 7 and 9 upon 11 first. 5 upon 7 can be rewritten as 5 into 1 upon 7. Now in the previous class, while solving this, solving for rational numbers, we found the value of 1 upon 7 as 0.142857, and these terms were recurring, right, from 1 to 7. Therefore 5 into 1 upon 7 is nothing but 5 into 0.142857. Let us calculate this into 5. 5 sevens are 35, 5 fives are 25 plus 3 28, 5 eights are 40 plus 2 is 42, 5 twos are 10 plus 4 is 14, 5 fours are 20 plus 1 is 21, 5 ones are 5 and 6 7, 5 ones are 5, 6 7. So how many digits? 1 2 3 4 5 6. So 1 2 3 4 5 6. So my decimal point comes here. Therefore this value is 0.714285. So I have found the value of my 5 upon 7, which is this, with a bar on top. Now let's go ahead and find the value of 9 upon 11. 9 upon 11 similarly can be written as 9 into 1 upon 11. We saw in our previous classes that 1 upon 11 is nothing but 0.09 bar, which is a repetition of 090909. This is also equal to 0.090909 and so on. So 9 upon 11 is nothing but 9 into this number 0.090909 and so on. So if you multiply and check, what do we get? This is equal to 0.818181 and so on. So which is equal to 0.81 bar. So we need to find how many irrational numbers? 3 irrational numbers between these two numbers. Now we can very easily find 3 irrational numbers between these numbers. How? because whatever we get as our answer for the irrational numbers, the decimal terms have to be non-recurring and non-terminating. So let's write few numbers. If I take 0.71, 714, 32685, 326852918, and so on. See, no pattern is repeating. So this is an example of a non-recurring, non-terminating decimal expansion. I can take another number, 0.801, 001, 001, 101, 001, 0001, then 4 times 0, 1, then 5 times zeros, 1, and so on. See, we have 01, 001, 0001, 4 times 01, 5 times 01. So even here no pattern is repeating. You might be wondering, because you might get sums like these in your exam, which is why I gave you an example of this sort. You must be wondering, we have a 1 and 0, 1 and 0 repeating, but it's not a 1 and 0. See, it is 1, 0 and 1, 1. Then 2 zeros and 1, then 3 zeros and 1. This is not a pattern, right? A repetitive pattern. So this is another example, because this number is also lying between 0.714285 and 0.81. Let's take another example. I will take 0.714286938219, and so on. Again here there is no pattern that is repeating. Can you just go through this and see if any pattern is repeating? It's not repeating. Similarly, we can find infinite number of rational numbers between any two given rational numbers or any two real numbers. Okay, so I'll write my answer here, or you can just refer to this. This is the answer to my 8th question. Find 3 irrational numbers between 5/7 and 9/11. You can write these 3 numbers. Also, please make sure that you solve this section, which is why I have solved it for you. Okay. Let's proceed to the 9th question now. So we need to classify the following terms as rational or irrational. Let's write down these numbers. The first one is root 23. Now 23 is a prime number. So the square root of any prime number is irrational. We have learnt that. Therefore this term is irrational. Let's check the second term. 225. Root of 225. We know that the square root of 225 is 15. Right? If you do not know how to calculate square root, let's take 225 and find the square root. So I have 5 4s are 20, 5 5s are 25, 5 9s are 45, 3 3s are 9, and 3 1s are 3. So you see 3 is repeating twice and 5 is repeating twice. So 5 into 3 is the square root of 225, which is 15. So 15, that is why this term is rational. Why rational? Because this is also a natural number. You can classify it as a natural number or a whole number or as an integer. Okay. Now the third one, we have 0.3796. Now this one is a decimal term with its decimal expansion as terminating. So this one is again a rational number, because in rational numbers the decimal expansion is either terminating or it is non-terminating but recurring. Let's take a look at the fourth one. You have 7.47, 8487 and so on. 7.478. I think I have made a mistake in copying the question. 478, it is 478. 478, 478 and so on. So here if you notice, these three terms 478 are repeating, right? So this can be this entire term can be written as 7.478 bar. So again we have a recurring pattern. This decimal expansion is non-terminating but recurring. Therefore this is a rational number. Let's take a look at the fifth one. You have 1.01, 001, then 3 times 01, then 4 times 01 and so on. Now again over here, see the decimal expansion. It is neither terminating nor is it recurring. You do not have any pattern. Therefore this is an irrational number. So therefore we have classified these numbers as rational or irrational depending on what numbers we get after the decimal expansion, or whether they belong to the rational number category or irrational number category. So with this we wind up exercise 1.3 of your chapter number system. We will continue with the rest of the chapter in the forthcoming classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.